Hey guys, welcome. We're doing a review video. This is for our second review, so our second review packet. Here we go. Number 1, 1 to 2, 2 to 3, then 1 to 3. That follows our transitive rule. So that's transitive. AB equals AB. Reflexive means it's like an exact mirror. Number 3 is multiplication. We're multiplying both sides by 2. Then we have addition property. So we're adding 9 basically to both sides, 9 and 9, and that's how we get this answer. The next one's division property. We're dividing both sides by 8. This is saying basically if B is between A and C, then AB plus BC would equal AC, so that's segment addition postulate. We have here symmetric property, and those are the first 7. Okay, moving our way down the paper. Sorry, I'm using a new video camera, see if it works better, a little higher quality, so you guys can be the judge of that. Alright, so moving our way down, number 8, it says 1 and 2 are complementary and 1 and 3 are complementary, then what must be true? The way we always kind of do this is basically just like to draw 2 angles, angle 1 and angle 2, and I give them 50 degrees and 40 degrees. It means they add to 90. And then what we can also do is say, alright, well if I have those 2, then I want to go ahead and say, alright, 1 and 3 are complementary, so if I had an angle 3, that would be 1 and 3, so 3 would have to be 40, which means 2 and 3 are congruent. Okay, so that's what we'd want to go with. Okay, alright, I'm just gonna put on an auto lock here real quick, so I feel like it's getting blurry. So boom. Okay, I think that looks better. Now it should focus or change focus. Okay. Number 9, it says find the slope of a line that is perpendicular to a line that passes through. So first we set up our slope formula over here. I got the work shown for it. I get my slope of 10 over 5, which is 2. Remember, perpendicular means opposite reciprocal, so we get negative 1/2. Number 10, true or false, 2 lines never intersect, they must be parallel. The answer is false. They could be skew, which if we had a box like this, the skew line could be this one right here in the front, and maybe this one back here. They wouldn't actually meet, but they'd be on different planes. That's why skew would work. Find the slope of a line parallel. Well, parallel means same slope. So parallel means same slope. So all I had to do is find the slope of this first one, which is negative 13 over 2, and then I just leave it. Don't have to change it. Okay? And moving our way down to number 12. Okay. Find the slope of the line perpendicular to this line. So the first thing we're going to want to do is find the slope of this line. So I'm going to subtract 7x from both sides, and that leaves me with this equation over here. I have to divide by negative 2, so I get 7 over 2. Perpendicular, I'm going to do the opposite reciprocal, so I get negative 2 over 7. Okay? Make it a little brighter. Okay, I thought we locked that, but I guess it kind of came undone. Okay, cool. Alright, number 13. Find the slope of a line perpendicular. Okay, when we do the slope, we end up getting 0 over negative 9, which is 0. The slope of that would be undefined because it would be 0 over 1, or in this case, negative 9. And you can't have 0 in the denominator here. Since you can't have 0 in the denominator, then we would call this undefined or no slope. Okay. Number 14 here. Number 14, we get write an equation of a line that's parallel to 2x plus 3y equals 9. First, we got to put it into slope-intercept form to get negative 2 over 3. Okay. Now, a couple ways that we could do this here. I'm going to show you 2. Take the slope, take the x and the y value from our point, which is 3 and 1. We can actually put in the y equals mx equals z, solve for b, and then plug it in. Or, I'm going to do it a different way over here. we could take point slope and go y minus y1 equals mx minus x1. And then I could go ahead and plug in my slope of negative 2/3 and my x value of 3 and my y value of 1. And I can go ahead and distribute the negative 2/3 all the way through. That's going to be y minus 1 equals, this is going to be negative 2/3 x. The x3's are going to cancel, it's going to be plus 2. Add 1. And I'll actually get the exact same answer right here as y equals negative 2/3 x plus 3. So 2 ways you can do that one. Same thing is done with this bottom one. Write an equation of a line. We get negative 10, 12, negative 7, 4. Use that to find the slope, which is 8 over negative 3. Okay, they put into y equals mx plus b form, and they plugged in one of the points, negative 10 and 12 and negative 8/3 to find b of the value of 44 over 3. Or we could just put it into y equals negative 8/3 x minus, I'm sorry, that's supposed to be a plus 44/3. Okay. Moving right along. Number 16, we factor this using our x factoring. Negative 14 and negative 5. The two numbers that go into that would be negative 7 and 2. So it's fully factored. This one here, we call it a difference of two squares. X squared and 25, they're both perfect squares, so we pull out 5, or x from there and 5 from there. And so we can do the difference because they'll cancel the middle term. Number 18 does not factor, so I got you guys, some of you do the quadratic formula, but it does say to factor only, so we're just going to leave it with do not factor. This one here, we could actually factor a 2 out in the very beginning. We get negative 8 and 12. So the two numbers that multiply to give me 12, and negative 8 would be negative 6 and negative 2. And that's fully factored. The 2 sitting on the outside. Okay. This next one here, it goes ahead and states that we have x squared minus 12x plus 36. And so we do go ahead and do what two numbers multiply to give me 36, but add to give me negative 12, and that would be negative 6 and negative 6. Okay. That one could also be written as x minus 6 squared. And the 7, 2, 16, and 10, the two numbers are going to be 8 and 2. The rest of these are just formulas, so I'm just going to put them up here. If you want to pause the video real quick, you can. Okay, and I'll go to the next section. You can pause the video if you want. Okay, pause them to get those answers. Alright. On the back, the following proof, which is the best answer from the reason bank to fill in. Okay, M is the midpoint of Ln. So M is the midpoint right here of Ln. If that's true, we know those would be probably equal to each other. So we give that. Lm is equal to Mn. We said that. That's the definition of midpoint. And then that one's already done. Okay. Next one, we go to number, our second one. And this one states, and this is supposed to be, I think, a D up here on that top angle. DMB equals AMC. Prove that 1 and 3 are congruent. So DMB and AMC are congruent, that's given. 1 plus 2 equals DMB, so here's 1 and 2, they add up, that's angle addition postulate. Then we substitute that, and 2 and 3 add up, that's also angle addition postulate. Since we know that these two, whoops, sorry about that. Since we know that these two equal each other, then what we're going to go ahead and do is set them equal to each other. And when they're equal to each other, we did a substitution property. We could go reflexive here. We could actually do some sort of other maneuver, but 2 is equal to 2, so we know we can subtract those from each other. So that's what we did in the next step. Step 5, we subtracted 2 from both sides to leave with 1 equals 3. Okay. Last but not least, A is parallel to B, and 2 and 3 are congruent. Prove that A is parallel to C. So we know A is parallel to B, and we know that 2 and 3 are congruent angles. Okay? So we're given A being congruent. 1 and 2 are congruent. We know that because if we have parallel lines, then corresponding angles are congruent. That's one of our postulates, so we know that these are congruent, 1 and 2. 2 and 3 are given. If we know 1 equals 2, then 2 equals 3, then 1 equals 3, that's transitive property. And if that's true, AC, we have 1 and 3 equal, then alternate interior angles are congruent, which they are. 3 and 1 are congruent. Then these lines, A and C, are parallel. Almost done. A couple more of these. Okay. RT and SU are perpendicular. T is the midpoint of SU. Prove S is congruent to U. Okay. So we go through all of our rules, all this stuff, and basically we want to find out what's equal to what. So what did we prove? We proved we have two angles are congruent. We proved a side, and we proved a side. Okay. And in the picture, we can see it's side angle side. That's how we pick SAS. And then we want to show that S is equal to U. Well, once I've proven the triangles are congruent, that's how I know corresponding parts of congruent triangles are congruent. Very important thing to know for the final. Okay. And then here we go. We have a rectangle. We're trying to prove FAC is congruent to CDF. Okay. Basically what we have here is we have a triangle FA is equal to DC, that's marked. And then FAC is equal to FDC, opposite sides and opposite angles in a rectangular congruent, so that's how we got those two reasons. Then FC is equal to FC, that's going to be a reflexive property. And then we know that FCA, or FAC triangle, FAC, so we proved hypotenuse, leg, and we had a 90. And then we have hypotenuse, leg, and 90, and that's how we get HI. Okay. Alright guys, that's the last one. Got that whole thing done in 12 minutes. If you need to review it again, make sure you review. If you need help, we can go over it on Friday and exam prep.